This is MATHguide.com, and my name is Mark Karadimos. So, I'd like to help you understand how to convert between degrees and radians. In order to do this, you first have to get a visual of what's happening with degrees and radians. So, imagine that you've got this circle, and I'm going to put the typical XY intersection right there. And let's say that you were going to talk about angles. Well, you would know that if you go all the way around a circle, that is 360 degrees. If you go all the way around a circle, we also know that that's 2 pi radians. Yep, 360 degrees and 2 pi radians represent the same angle, which is a complete turnaround, or a full circle. So let's put that on hold for a moment. Now let's think about something that we should already know, like for instance, 3 feet. So if someone said, hey, that length is 3 feet, I'd like to know how many inches that is. Well, what do? Well, some people do this in their head, but if you want to show this on a mathematical level, what you would do is you'd multiply by something called a conversion factor. Okay, what is a conversion factor? You take a ratio of two quantities that have the same value. Okay, like for instance, I know, and you should know, that 12 inches is 1 foot. So I need to figure out how to arrange this ratio. 12 inches is 1 foot. See, I could put 1 foot over 12 inches. But if you know anything about math, I can't cancel any units. So the only way you can cancel units is if a numerator has the same unit as a denominator, and then I could cancel some units. This isn't working. See, I can't cancel anything. There's nothing, no feet on top with feet on the bottom. Can't cancel. Bad arrangement for my ratio. So instead, what I'm going to do is I'm going to back up, and I'm going to say, well, what if I put instead, since I've got feet here in the numerator, I'm going to put feet down here, and I'm going to put inches up here. So I know that there's 12 inches in 1 foot. That is the correct arrangement. It's the correct ratio. I do know that 12 inches is 1 foot, and the benefit is that something cancels. Like for instance, I have feet in the numerator, feet in the denominator. I can cancel, as they say in math. Okay, now that I've canceled those units, I now multiply straight across. Yeah, this is a fraction. I could put this over 1. It's a fraction. See, feet on the top, feet on the bottom. All right, well, now what do you do when you're multiplying fractions? You multiply straight across. So I'm going to multiply 3 times 12 is 36. Yep, 1 times 1 is 1. The only unit left is inches. It's in the numerator. So my answer really is just 36 inches. Yeah, I know, you probably could have done this without a conversion factor. But this is how the math works. And this is really helpful, especially when the units get nutty. And you got units all over, and you're converting from feet to kilometers or centimeters, and it gets really wild, and you use a number of these conversion factors. Okay, let's get back to degrees and radians. All right, so how do we now use these unit conversions to work with degrees and radians? Well, we know that 360 degrees is the same thing as 2 pi radians. Or we could look at it as 2 pi radians is the same thing as 360 degrees. You know, when you set up these conversion ratios, you could set them up either way. All right, but before we use these conversion ratios, let it be known that you could actually reduce these. We could make these actually easier to work with. So for instance, I could divide the top by 2, and I could get 180 degrees. And I could divide the bottom by 2, and I could get pi. And the same thing right here, right? Just dividing the top and bottom by 2. It's called reducing, right? You could reduce ratios or reduce fractions. So instead, when we use our conversion ratios for degrees and radians, we're not going to use these. Instead, we're going to use these. They're easier to work with. Let's do that in the next section. All right. Let's start with 120 degrees. Let's say we're asked to convert this into radians. So what you have to do is determine which conversion ratio to use. So do I use 180 degrees over pi radians? Or the reverse, do I put pi over 180 degrees? Well, here's how you determine that. So think of this as a fraction. I have got degrees in the numerator, so therefore the only way to cancel degrees is to get the degrees in the denominator in our conversion ratio. So in other words, I have to put the 180 down here. See, I'm setting this up so the degrees will cancel. If I do it the other way, 180 on top and pi on the bottom, nothing cancels. It's not the right way to go. You always set this up so that something cancels. See, right now I could cancel the degrees, so to speak. All right, I could also divide these two numbers by 10. So I'm going to divide them both by 10. Now if I do that, 120 divided by 10 is 12. 180 divided by 10 is 18. But we could go farther. Let's reduce again. Like for instance, I could divide both of those by 6. Divide that by 6. Divide that by 6. So if I divide 12, 12 divided by 6 is 2. 18 divided by 6 is 3. And there you go. I can't reduce anything anymore. So now what do? You multiply across. That's how you multiply two fractions. You multiply numerator times numerator, denominator times denominator. So 2 times pi is 2 pi. 3 times 1 is 3. And there you go. Sometimes people write it instead of 2 pi thirds. I have also seen it as 2 thirds pi. They mean the same thing. Let's take a look at another example. So let's say someone gives you 5/4 pi. 5/4 pi. And they say, we would like to have this converted into degrees. Well, 5/4 pi, looking a little messy for my sake. So what I'm going to do is I'm going to think of this as 5 pi fourths. Makes it a little bit easier to understand. All right, again, I've got to figure out what the conversion ratio is. See, you got to get this conversion factor right, otherwise it's not going to work. So here you can see that I've got pi. I'd like to be able to cancel this pi. So when I set up my ratio, I'm going to say, well, I've got pi on top, I want pi on the bottom, and I know that the conversion ratio is pi is the same thing as a 180 degrees. See, always use that ratio. It's either 180 degrees over pi or pi over 180. And this is the way it's going to work for this problem. So right away, things are looking great because I could reduce that. Again, I'm dividing the top by pi, and I'm dividing the bottom by pi. So technically, I'm going to put little ones there. Can we reduce some more? Sure can. So if you notice, I've got 180 and 4. I could divide both of those by 4. So I'm going to divide that by 4. I'm going to divide that by 4. So 180 divided by 4 is 45. And I haven't lost the degrees yet. The degrees are still there. And 4 divided by 4 is 1. So I just divided them both by 4. All right, now how? Oh yeah, and I'm done reducing. There's nothing else I can reduce. I only have 1s at the bottom. Can't reduce it any more than that. So when I multiply across, again, I'm going to multiply numerator times numerator, denominator times denominator. 5 times 45 is 225. And there you go. Thanks for watching. And if you go to MATHguide.com, there's more instructional videos, interactive quizzes, and of course text-based lessons. Take care. Have a great day. Radians, so radical.